A winnower is a farm machine used to separate the chaff, straw, and immature grain from rice or beans after harvest. In Japan, winnowers came to be used to separate rice in the latter half of the 17th century in the Edo period and made a great difference in the amount of labor required to separate post-harvest rice. Winnowers are manually wound to generate the wind for winnowing. The use of winnowers far outperforms wind separation that uses natural wind power for winnowing. The structure of the winnower is very simple. In addition, they are light and relatively easy to carry, and it doesn't cost much to make one. A winnower is made up of 4 components: a winnowing fan, which produces wind, a hopper, which feeds in the paddy, a wind duct, where separation is carried out by wind, outlets, which discharge the separated materials. Let's take a look at how one works before showing how to make one. Put the harvest in the hopper and turn the fan. Open the hopper opening. The wind blows away lighter materials such as chaff, straw, or immature grains. Heavier whole grains are discharged through the first outlet. The materials that come out of the second outlet still contain unseparated grains. Therefore, you need to winnow them again to get a higher level of separation. Winnowers come in various sizes and heights depending on what crop is to be separated or who operates it. Today, we will introduce a winnower used for Japanese rice. To begin with, we are going to make the most important element of the winnower, the fan. The fan is composed of 4 blades. Each blade is fitted with 4 axes connected to the shaft. Here is the set of components necessary to make the fan. Let's make a pipe to connect the shaft and the fan. Here are the dimensions for the pipe. Weld a square iron plate to the round bar. There are 2 points to note. The first is to fix the iron plate to the center of the round bar. To do so, make a metal support as the center reference in advance and weld it under the assembly. The second point is drill in screw holes for attachment to the shaft and the iron plates, putting the holes on diagonal lines of the square. Then later, when you attach the bearing to the shaft, you can do it very easily because the holes will be located exactly between the blades. This is where a lot of force will be applied, so weld at 4 locations on each side, 8 locations in total. We are going to make 4 axes for the fan. Here are the dimensions. For 3 of them, modify the edge of the bearing side as you see in this picture. Weld the bearing to the axes. The important thing is to weld the axis of the uncut side first. It may be a good idea to number them in advance in the order they are to be welded. It is easier to make a straight weld if you mark the center of the axis. Firmly weld the remaining 3. For the last one, since the bearing and the part to weld are hidden, it is impossible to weld. So directly weld it to the first and third axes. Set the axis on the center of the blade and weld them. Here is the dimension of the blade. Cut one axis at 2 locations. Bend it 90 degrees at the parts with the dotted lines in directions opposite each other. You can get a strong weld if you use a wooden stand that is just as tall as the height of the axis. You could also make a fan out of wood. In that case, use a metal pin to connect the fan to the shaft by inserting it into the shaft. Next, we are going to make the housing for the fan. The housing is made of 3 bent iron plates and 2 round wooden side plates. Here are the dimensions. We used a 12 mm thick plywood board for the side plate. The iron plate used is 0.8 mm thick. It is bent with a 3-roll bender. Bend it steadily as you push along the curvature of the wooden side plate. When you finish bending, fold the edge to make a bending margin. Fold only one end for 1 and 3. For 2, fold both ends. These are the dimensions for the bending margin and the bolting positions. If you drill a screw hole before rounding the iron plate, the hole may be warped by the pressure of the roller. It is important to round the plate before drilling any holes. Bend it outward at a right angle at the bending margin. Temporarily tighten them and check if the 3 iron plates are properly connected. If they are, drill screw holes for fixing iron plates 1 and 3 to the side plate. Drill a center hole in the side plate. Drill a hole 20 mm in diameter to run the shaft through at the center of the side plate. Fix iron plates 1 and 3 to the side plate. We don't fix center iron plate 2 to the side plate because we need to make it detachable for adjustment. Now we are going to make a frame that fixes the shaft using an iron plate. Here are the dimensions for the frames of both sides. Weld the shaft to one frame. A pulley is going to be attached to the shaft later. The hole through which you are going to put the bearing is 42 mm in diameter. Let's drill a small hole first and then gradually make it bigger. Keeping the shaft in the hole, set the frame against the side plate and fix them with screws. After fixing them together, temporarily fix the fan to the shaft, rotate the fan, and make sure there is no warpage. Now, we are going to make a hopper. Prepare 2 kinds of 1 mm thick iron plates, 2 of each. Here are the dimensions for 1 and 2. Bend the plates inward at 3 locations, 1 and 2 on the left and right, and 3 on the top. Bend the left and right splices 65 degrees. Bend the top 95 degrees. Assembling the hopper. Put the inner sides of iron plates 1 together, making sure to neatly align the lower edges. Hammer the top corners outwardly in advance so that they won't hit. firmly fix them with a small vise and weld them. Make a cut in the top corners and keeping them bent inward, weld them to firmly fix them in place. For extra safety, let's polish them with the sander. Finally, check to see if there is any warpage. Let's make a wind duct. We are going to use 3 1.5 mm thick iron plates to make the wind duct. Here are the dimensions of the upper plate. Here are the dimensions for the bending margin of the upper plate and the screw holes. Here are the dimensions of the side plates. Holes for 6 mm diameter bolts should be 7 mm in diameter. When you drill holes in the side plates, put 2 plates together and drill the holes for efficiency. Remove burrs. Bend the upper plate at 3 locations. First the top part, then the 2 jointed parts on the side. When you bend the sides, the top part will be deformed, so you will need to hammer it back into shape. Temporarily bolt the side plates to the outside of the upper plate. This has completed the wind duct, although tentatively. Let's assemble the stand. The stand is the framework of the winnower. We are going to use 6 angle bars, each 25 mm in diameter, for each side. Check the figure and cut them to the right dimensions. Drill holes for bolts. Holes for 6 mm diameter bolts are 7 mm in diameter. The key to stand assembly is to attach the fan and the wind duct separately and then join them together afterward. First, attach the angle bars to the fan. Vertical angle bars should come first. Be sure to use washers when you fix the angle bars with the bolts. The bar we are now working on is the one to join to the wind duct. When you are done with one side, turn it over and do the other side the same way. Attach the angle bars to the wind duct. The key here is to provide a support such as wood to stabilize the angle bar. When you fasten the bolts, start from the upper plate. Now 2 bars are fixed and one side is completed. Turn it around and do the other side the same way. Now join the fan in the wind duct. Remove the joining angle bar attached to the fan side. Then join the fan to the wind duct. Fix both of them with the angle bar you just removed. When you fix one side, stand the main body up and fix the other side. When you finish joining them, attach a vertical angle bar to a long horizontal angle bar and firmly fix the stand. In addition, use a short angle bar to reinforce the stand. Reinforcing angle bars should be used at the following 6 locations. Next, we are going to make outlets from which the separated paddy, chaff, and other waste are discharged. There are 3 outlets, and we are going to make 2 of them. Use a 1 mm thick iron plate to make the first and second outlets. These are the dimensions for the first outlet. Bend it 90 degrees along the black marker line. Place the bottom plate and the side plate together and cut any protrusion of the bottom plate. Firmly immobilize both ends with a small vise and start welding. Try to use wood for support to ensure good welding. Fix the upper plate and weld. Any protrusions should be cut away. Here are the dimensions for the second outlet. Bend and weld using the same procedure for the bigger one. After cutting both, file them down. Now the bodies of the first and second outlets are both completed. Next, let's make 4 shift rails to which the first and second outlets are to be inserted. Use angle bars and iron plates to make the shift rails. Here are the dimensions of the shift rail parts. Drill holes for welding in the iron plate and fold it at right angles. Insert a 3 mm thick iron plate between the angle bar and the folded iron plate and weld them. Now you can easily make the shift rails with the same clearance. When you weld, firmly fix the parts with a small vise. Now the shift rails are fully completed. Next, attach the shift rail for the second outlet. For the clearances made from the joint of the angle bar, join them with a 16 mm square pipe. For shift rails, where the second outlet and the first outlet are side by side, install them together. You don't need a square pipe to install the shift rail of the first outlet close to the fan. We recommend you put the necessary bolts, nuts, and square pipes together with the shift rails at the assembly location in advance. After installing the shift rails, check if things can pass smoothly in and out of the outlets. The role of the 4 kinds of fixed cover plates is to fill the clearances between parts or adjust the angle of the adjusting plates. The figure shows the 4 locations where you should install the fixed cover plates. For convenience, we will show the numbers to indicate the order of installation. Let's check 1. 1 is the fixed cover plate to be installed at the hopper socket. The bending angle is about 135 degrees. Weld it to the inside of the wind duct. You can see the marks left by welding. 2 is the fixed cover plate to fill the clearance between the fan and the wind duct. Bend it to match the clearance. Detach the rail of the first outlet, the one closer to the fan, and weld the plate to the rail. After welding, install it to the stand again. Three is the fixed cover plate that covers the first and second outlets. The plate here should be made triangular as seen here. Bend it accurately 70 degrees so that it can properly straddle the rail. Weld the triangular plate with screw holes. Attach it to the stand and firmly fix them with bolts. For the fixed cover plate 4, install it to the front side angle bar so as to cover the clearance of the second outlet. Bend it to the appropriate angle like the other fixed cover plates so that the patty can easily be blown to the outlet. The angle here is about 140 degrees. For the angle bar to which the iron plate is attached, weld a square iron plate with screw holes like these to the bar in advance. Weld the angle bar and the iron plate to finish the assembly. Firmly fix it to the stand with bolts. Now we are going to make an adjusting plate used to adjust the amount of patty thrown in or discharged. It is essential that the adjusting plate be made to ensure smooth vertical movement. 4 adjusting plates are necessary, 2 at the hopper sockets and another 2 at the outlets. Each of those plates is slightly different in shape and how it is made, so check the figures while making them. First, let's look at 1. Here is the set of components. Let's make fasteners. Weld a nut to a 16 mm square pipe. Drill a hole in the pipe to match the diameter of the nut and thread the hole. Weld it to the iron plate. Now we've got adjusting plate 1. Put the shaft through the square log of the adjusting plate with the pinhole at the front. Fix one end with the pin and attach the handlebar. The handlebar is made out of a 10 mm thick aluminum plate using a lathe. Fix the adjusting plate to the shaft. After fixing, test if it moves smoothly. This adjusting plate serves as the stopper. Next, install 2. It is necessary to attach the bent plate to this plate to ensure the patty falls properly. The curvature is R45. Install a 16 mm square pipe vertically to 2. Put the shaft through it to stabilize the assembly, and you can weld it more easily. Be careful of the bolt positions too. Weld the plate bent toward the bolting side to the lower part. Like 1, put it through the shaft and fix them. After attaching it, check that the plate can rotate smoothly. Let's make 3 and 4 together. Although they are the same size, can you tell that they are different in the position and the direction of the fastener? Relative to the iron plate, the fastener is placed horizontally for 3 and vertically for 4. The installation position is just above the triangular fixed cover plate in the back for 3 and above the fixed cover plate located at the outlet for 4. This is the end of the adjusting plate installation procedure. Next, we are going to assemble the support for the hopper with 4 iron plates. The important point is the installation angle. We should check the angle by actually putting the hopper on it. Adjust one angle to the slope of the hopper and cut it. Cut the angle bar to the same angle. Temporarily place the hopper and install the horizontal support first. Then, install the diagonal iron plate and firmly fix it with a small vise. Grind and weld it. Lastly, check the detailing of the hopper. Install the pulley that rotates the blades. Here is the set of components. Larger pulleys are 200 millimeters in diameter and smaller pulleys are 60 millimeters in diameter. We will use A43 type of V-belt. For the manual handle, we are going to use long hexagon bolts, 2 nuts, and a pipe larger in diameter than the bolt. Install the larger pulley at the end of the fan frame. Install the smaller pulley at the shaft. Use washers for both of them to prevent dislocation. Place the belt, determine the position, and fix the pulley. Do not tighten belt too much, give it some slack. If the fan does not hit anything and smoothly rotates, it will be okay. Lastly, finish the corners of the angle bar by rounding them to make it safe for users. Now the winnower is complete. Now let's use the completed winnower. First, load the patty into the hopper. Start rotating the handle. When the fan rotation becomes stable, slowly open the adjusting plate 2 of the hopper socket. At first, keep the adjusting plate open just a little, and when you decide the chaff is properly separated and discharging from the outlet, open the adjusting plate much more. Indications of proper operation are the good patty coming out of the first outlet, the less good patty out of the second outlet, and husks and dust out of the third outlet. If you see good paddy coming out of the third outlet, stand adjusting plates 3 and 4 up slightly and reduce the fan speed. But if chaff or straw is mixed in the materials discharged out of the large outlet, lower adjusting plates 3 and 4. You can also adjust the amount of paddy with 1. Once separation is over, return the paddy out of the second outlet to the hopper for further separation. Repeating this procedure, we can get fine grains out of the first outlet. How did the participants of the program feel about the winnower?
I am Engineer Olushola Adetola Ogujirin, working with National Center for Agricultural Mechanization, Nigeria. I have been working on winnowing machine during the course of my training in JICA here in Tsukuba, and it has proved to be very efficient, and it will be useful for the rural farmers who need to clean their grain at the right time. And also, cleaning the grain improves the quality of the seeds such that it can attract more pricing from the market. Thank you.
How was it? Anyone can make a winnower with basic agricultural skills like welding and some plates. The size of the winnower or the position of the fan differs depending on the crop. Please use the winnower used in this course as a model and make your own that is matched to your purposes.